Hey everybody, today we're going to go over graphing linear inequalities. We did this in class, but I thought it'd be worthwhile to go over the answers to this, because I know some people definitely had some questions. So the first things we need to understand is that this inequality symbol will dictate the type of line we're going to use. It's either going to be a dotted line or a filled in line, and that really matters if it's inclusive or not inclusive. So if it's going to be greater than or less than, it's going to be a dotted line. Okay, because it's not inclusive. If it's greater than or equal to or less than or equal to, it's going to be a solid line because it is inclusive. All right, I think I'm actually going to use a pen because it'll come up better. So don't do a pen for this, though. I would definitely recommend using a pencil when you're doing these. All right, so we have y is greater than negative x minus plus 5, rather. So the y-intercept, which would be, let's see, y equals mx plus b. The y-intercept is positive 5. It's going to go here. The rate of change is negative 1. So we're going to go down 1 over 1. And I'm just going to plot as many points of these as I can. I always get nervous using a pen when I graph, because I always feel like I'm going to mess it up. Now it's not inclusive, so it's going to be a dotted line. There you go. Just like that. And now we need to use our test point. So the best test point to use is the origin. The only time we can't use the origin is if the line goes through it. So we're going to plug these values in to see if we get a true or false statement, because we need to see which side we're going to shade. So y is greater than negative x plus 5. We're going to plug in 0 for x and y. So 0 is greater than negative 0 plus 5. Negative 0 plus 5 is 5. Is 0 greater than 5? No, that's false. So that means this is not part of the solution, which means the other side has to be. So that's our answer. Okay, let's get going here. So we got y is greater than negative 5x plus 4, so 4 is our y-intercept. Negative 5, so we can go down 5 over 1, so 1, 2, 3, 4, 5, right 1. And 1, 2, 3, 4, 5, right 1. There we go. This is going to be a dotted line, because it's non-inclusive. Okay, we're going to use our test point. We should label that TP for test point. So y is greater than negative 5x plus 4. 0 is greater than negative 5 times 0 plus 4. This is 0. So 0 is greater than 0 plus 4, which is 4. That is a false statement. So it means this is the solution. Let's try this over here. So 3 is our y-intercept. Our rate of change is 1, because there's a 1 there. So up 1 over 1. It's positive slope, so we're going to up and to the right. And down and to the left. This is going to be a solid line because it's inclusive. Okay, let's use our test point. Y is less than or equal to x plus 3. Plug in 0, so 0 is less than or equal to 0 plus 3. 0 is less than or equal to 3. This is a true statement, so that means this is part of the solution. There we go. All right. Plus 4. 4 is our y-intercept. 2 is our rate of change, so up 2 over 1. Here we go. Just like that. It's going to be a dotted line because it's not inclusive. And again, if you don't have access to a printer, it's no big deal. You can still edit your PDF using your Chromebook, as we showed in class. So y is greater than 2x plus 4. Plug in our test point, which is 0, 0. So 0 is greater than 2 times 0 plus 4. This is 0. 0 plus 4 is 4. So 0 is greater than 4. That is definitely false. So this is part of our solution. Okay. So 5 is our y-intercept. Our rate of change is 1/4, so we're going to go up 1 over 4 because it's a positive slope. And down 1 left 4. And this is a solid line because it's inclusive. There we go. Let's see our test point here. So y is less than or equal to 1/4 x plus 5. 0 is less than or equal to 1/4 times 0 plus 5. This will equal 0. 0 plus 5 is 5. So 0 is less than or equal to 5. That's a true statement. So this is included in the answer. Last one on this side. Y-intercept is 1. The rate of change is 5/3, so we're going to go up 5 over 3. 3, 4, 5, and 1, 2, 3. Then go down 5, 1, 2, 3, 4, 5, and left 3, 1, 2, 3. And this is going to be a dotted line because it's non-inclusive. Let's see our test point. So y is less than 5/3 x plus 1. 0 is less than 5/3 times 0 plus 1. 0. 0 is less than 0 plus 1 is 1. 0 is less than 1. That is a true statement. So there you go. So that's basically how you graph these. Now, the back side where I'm going to show you this involves a little bit of groundwork before you can do that. Okay. So here you'll notice these inequalities are written in standard form. They're not in slope-intercept form. So what that means is we need to get the y by itself. So let's go ahead and do that on this side here. So we're going to have x minus y is less than or equal to -4. So we need to isolate the y. So we're going to subtract x from both sides. This goes back to our work with literal equations in algebra 1. Negative y is less than or equal to negative x minus 4. You need to divide by -1 or multiply by -1. Oh, there's the cat. Hold on a second. Yep, she has a habit of doing that. So anyway, let's get the y by itself. So we're going to divide by -1, which is the coefficient. Divide everything by -1. And that makes this become y. This becomes positive x, and this becomes positive 4. Now, the one thing you need to remember when you do this, if you multiply or divide both sides by negative of an inequality, this changes direction. So this now becomes greater than or equal to. So now we graph that. So if the y-intercept is 4, it's a rate of change of 1, positive, so we're going up and to the left. We'll plot all these points. And it's a solid line because it's inclusive. There we go. Okay, now let's see if its test point works or not. So that's a test point. 0 is greater than or equal to 0 plus 4. 0 is greater than or equal to 4. That is a false statement, so therefore it's that side. Okay. All right, let's see. So 4x plus y is less than or equal to -1. Let's subtract 4x from both sides. And we're going to get y is less than or equal to -4x minus 1. Alright, so our y-intercept is going to be -1. Our rate of change is -4. So we're going 1, 2, 3, 4, right 1. And 1, 2, 3, 4, left 1. 1, 2, no, we can't fit the other one. And this is going to be a solid line because it's inclusive. Okay, use our test point, which is awfully close to line, but it's not a line, so we can still use it. So plug in zeros for our coordinates. 0 is less than or equal to 0 minus 1. 0 is less than or equal to -1. And that is a false statement. 0 is larger than -1. Be careful. So because it's false, we're going to go away from the test point. Okay. So we have 5x minus 3y is greater than 12. And we want to get y by itself, so we're going to subtract 5x from both sides. So we're going to have -3y is greater than -5x plus 12. It's a positive 12, right? We divide by -3. So we divide everything by -3. And that's going to become y is, and this changes direction now because we divide everything by negative, less than positive 5/3 because they negative divide by negative, they're positive, and then positive 12 divided by -3 would be -4. Okay. So our y-intercept is -4, which is down here. Our rate of change is 5/3, so 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 1, 2, 1, 2, 3. And this is going to be a dotted line. because it's non-inclusive. 0 is less than 5/3 times 0 minus 4. 0 is less than 0 minus 4. 0 is less than -4. That's a false statement. Right. Because it's false, we're going to go away from the test point. So there you go. Okay. Let's try this one. We have time. So 8x plus 3y is less than or equal to 12. We want to subtract 8x from both sides. So we have 3y is less than or equal to -8x plus 12. We then divide by our coefficient, which is 3. And we're dividing by positive, so we don't need to worry about the symbol changing. So y is less than or equal to -8/3 plus 4. Oop, forgot the x, that'd be important. So our y-intercept is 4. And it's -8/3, we're going to go down 8/3. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. And that's going to be a solid line because it's inclusive. Let's use our test point. 0 is less than or equal to -8/3 times 0 plus 4. 0 is less than or equal to 0 plus 4. 0 is less than or equal to 4. That is a true statement. So that means it's included in the answer. There we go. And the last two, here we go. So you can tell these take a little bit of time, these ones. 3x plus y is less than or equal to 1. Let's get y by itself. We're going to subtract 3x from both sides. So we have y is less than or equal to -3x plus 1. So our y-intercept is 1. Our rate of change is -3. So 1, 2, 3 over 1. 1, 2, 3 over 1. And we're going to go up 3 and left 1. 1, 2, 3, left 1. Right. And this is going to be a solid line because it's inclusive. And our test point's right there, right next to the line, but not on it. So 0 is less than or equal to -3 times 0 plus 1. 0 is less than or equal to 0 plus 1. 0 is less than or equal to 1. That is a true statement. 0 is definitely less than or equal to 1. So because it's true, it's included in the answer. And then the last one, we're going to rewrite this inequality. So we're going to write 2x minus y is less than or equal to -3. So minus 2x minus 2x. Negative y is less than -2x minus 3 divided by -1. And we have y is, now this is going to change direction because we're dividing by a negative. Greater than -2 divided by -1 is positive 2x, and that's going to become plus 3. The y-intercept is 3. Rate of change is 2, so up 2 over 1, or down 2 left 1. Okay, this is a dotted line because it's non-inclusive. Here we go. Okay, use our test point. 0 is less than, or greater than, sorry, 0 is greater than 2 times 0 plus 3. 0 is greater than 3, because 0 plus 3 is 3. Is 0 greater than 3? No, it's not. So it's a false statement. So there we go. All right, so that covers that. Now there's a second activity sheet on this, on graphing linear inequalities. If I have time later today, I will try to get that up today. If not, I'll make sure I get it done tomorrow, okay, because I think it's worth spending the extra time practicing this. So I hope that was helpful. Let me know if I made any mistakes, guys. Thanks for watching.